Math 205, Winter 2020, Homework 21, 4.2, Linear Transformations. A linear transformation T is a function from one vector space V to another one W. So let's talk about what a function is. Many books, ours included, give the unhelpful definition of a function as a rule which assigns to each x in one set a value y in another set. Usually the two sets here are the real numbers or some subsets thereof. But what is a rule? What does assigns mean? These are not previously defined mathematical terms, so it's bad to use them in the definition of something new. The official definition is this. A function is a set of ordered pairs with this property. If two ordered pairs are different, their first elements must be different. Let's agree to write OP in place of ordered pairs. This definition is motivated by our use of tables to help us draw graphs of functions. To graph the squaring function, which we normally write as f of x equals x squared, we might make a table of ordered pairs like the one on the right. Notice that the table does not have two ordered pairs that are different, yet have the same first element. This list of ordered pairs satisfies the property in the definition above. The ordered pairs minus 2, 4 and 2, 4 are different, yet have the same second element, but that does not violate the property in our definition. And the ordered pair 3, 9 appears twice, but that's merely a waste of paper. However, if the table contained 3 minus 9, the set of ordered pairs would no longer be a function. That's because 3, 9 and 3 minus 9 are different ordered pairs, and yet they have the same first element, a violation of the property in the definition. We're used to saying, when x is 3, f of x is 9. Or, when x equals 2, f of x is 4, and so on. But we could instead say, the ordered pair 3, 9 belongs to the function f, or the ordered pair radical 2, 2 belongs to f, and so on, in place of f of 3 equals 9, or f of radical 2 equals 2. You once learned the vertical line test. It says f is not a function if its graph has 2 points on the same vertical line. That is, 2 points of the form a, b1, and a, b2, where b1 and b2 are different. For most of the functions we study, there's usually a formula given. You put the first element of the ordered pair into the formula and do the computations, and out pops the second element. When we write f of x equals x squared, we are saying that when the first element of an ordered pair is x, the second one shall be x squared. Such a formula must be consistent. Given a first element a, the formula cannot produce b1 sometimes and b2 others. In class we did a non-example. We said, let f of x equals something you buy that comes packed x at a time. So what's f of 12? Eggs? Donuts? Pencils? Can the three ordered pairs 12 eggs, 12 donuts, and 12 pencils all belong to the same function? Finally, when a function f is given by a formula, the domain of the function is a set A of all the elements for which the formula can be computed. The codomain is any set B that has all the second elements produced by the formula, and possibly more. We are not required to see that each member of B appears at least once in some ordered pair in the function. For example, if we say let f of x equals x squared, then the domain is the set R of all real numbers, because you can compute x squared for any real number x. The set R can also serve as a codomain, but of course none of the negative numbers in the real numbers will appear as second elements. The smallest possible codomain, in some sense, is the set of numbers from 0 to infinity. We write this symbol f colon a arrow b, and it's shorthand for the expression f is a function from a to b, or f is a function with domain a and codomain b. The range is the exact set of second elements that appear. it's a subset of B. Note the range of f of x equals x squared is the set from 0 to infinity.